Hi everyone, hope you're doing well. This is a video for day 87. It's actually our last day of transformations, and most kids tend to find this day the toughest, so that's why we decided to teach it after the quiz and not quiz you on it to give you a fair shot. So this is sequences of transformations, so it's everything that you already know. We've actually already done sequences where I give you a couple of different sequences and you guys graph them, and kind of this is just the opposite of that. It's where they're already graphed for you and you need to figure out what sequences were actually done. Okay, there is one question on the final of this, but it is multiple choice, so that's, you know, something positive. So just try your best with this, try your best with the homework. The homework worksheets, everything on my website, and then when you're done with the homework tonight, please post it onto Google Classroom so you get credit. And again, just try your best, okay? You know all the basic transformations because you just had your quiz on it. Now just apply it to this. So again, try your best. Here we go. Directions. Identify the sequence of transformations from the original to the final image. Tell whether, so we're going to identify the sequence, and then we're going to use those words rigid or non-rigid. Okay, so this is our original right there. Again, I know it's original because it doesn't have any primes on it at all. And then this one right here is my first image. It has the primes. So if you notice, same shape, same size, so dilation's out, and these face in opposite directions. Here the A is up on top, and here it's on the bottom. So this is a reflection, reflected over this line. So number one is going to be reflection over the x-axis, reflection over the x-axis. Okay, so now I want to know, well, what did you do to get from this second one, right? So this is your first one, this is your second, and this is your third. So from the second to the third, what did we do? Okay, so this is where it starts to get a little tough. So it's the same shape and same size, so you know that dilation is out. They basically do not face in the same direction, right? That's what we knew here. We knew this was not a translation because they were in opposite directions. That's what we know was reflection. If you folded this over the y or over the x, it would not match up. Okay, so it can't be reflection, dilation's out, translation is the only thing left is a rotation because this was turned. If you took this figure and you turned it about the origin, okay, it would look like that. So it's going to be a rotation of 180 degrees. Actually, you could also say, or reflection over the origin. Okay, and you can just simply see that. I'll just do this point right here because it's probably best to show you. B prime is -1, -4, and we know reflection over the origin, you change both. So double prime is +1 and +4. So see how both of the signs changed? That's how you know it was reflection, or you just basically look at it. All right, next one. So we're going to start with our original, so right here. So from the first one to the second one. So here is your second one. Okay, so what do we see? Same shape, same size, so no dilation. If you look, A is here on the left, bottom left, and it's still here. A, B, C, so they're in the same exact order. When they're in the same order, all it did was just slide over. So we know it's going to be a translation. And then you want to count. So from here to here, 2, 3, 4, 5 left, and then 1, 2, 3 up. So translation, 5 units left and 3 units up. All right, so now from the second one, so the image with the primes to the double primes. Well, what do you notice? So right away, I notice the size changes. So I know this is going to be a dilation. Oh, by the way, we didn't answer this. Because they're all the same exact size, these are going to be congruent or rigid. Same exact size is congruent or rigid. I noticed this right away, different size. I can answer this right away. These are not going to be the same size. They are similar. Okay, so dilation, and you want to write by a scale factor of, and we kind of try our best to figure out what the scale factor is. You can do it one of two ways. Just look at the numbers. So this dot right here is -3, -1, and its corresponding, a double prime, is -6, -2. So what did you multiply those numbers by to get to be this? And that is 2. Some people just like to eyeball it. This looks like it's 1, 2, 3, 4, 1, 2. So 2 diagonal boxes, 1, 2, 3, and 4. How do you go from 2 to 4? And that's multiplied by 2. Okay, you're not really supposed to count the diagonal boxes, but you can if you need to. All right, number 3. So we're going to start with the original. Where's the original? This is the original right here. And then we're going to go to number 2, which has the single primes. Okay, so this is 1 and this is 2. So right away I see different size. So it can only be one of them. It has to be dilation, and I'm circling similar because they're different sizes. And you want to write by a scale factor of, and let's see, we can go by dots. We have -2, 1, and then a double prime is -4, 2. So how did I go from here to here? What did I multiply by? And again, it is 2. Or you notice that this side length is 2, this side length is 4, so it doubled, and that is 2. Okay, from the orange to the pink now. From the second to the third. So size does not change, dilation's out. If you look at the order of the letters, A is to the left, B is to the right. A is to the left, B is to the right. It's the same order. When it's the same order, it means you just slid up. So that's going to be your translation. So translation, we got to count though. So it's 1, 2, 3 to the right, and 1, 2, 3 up. Translation, 3 units right, and 3 units up. All right, number 4. We're going to start with our original. That's number 1. And number 2, this is our single primes. Okay, so the size did not change, so it's not dilation. They're definitely not facing in the same direction, so it's not translation. So it's rotation or reflection, and hopefully you can see that they just look like they're mirror images of one another. So that's going to be a reflection. And it's reflecting over this mirror line. This is the one you could fold it over and it would match up. So that's reflection over the x-axis. All right, so now we're going to go from the orange to the pink. Okay, so orange to the pink. So size did not change, so that's out. They're not, so dilation's out. They're not facing opposite directions. Reflections are out. It doesn't really look like it turned at all. It just looks like this figure just slid over. So we know sliding is translation. So it's going to be translation. So go from corresponding points. 1, 2, 3 to the right, and 1 down. So 3 units right, and 1 unit down. They are all the same exact size from beginning to end, so that is going to be congruent. All right, first page done. Hopefully you're doing okay. All right, what do we got next? Draw a similar figure. So we already know it's going to be different size. And it does say a similar figure. Based on the given sequences of transformations, state the coordinates of the original and image. Original and image. And we're only drawing one. All right, let's see what this is. So draw a triangle. Well, let's start with this. This might be the easiest. So point A is -5, 5. B is 00. And C is -10, 0. All right, so I did that. That's done. You want to dilate it. Oh, so this is kind of what we were doing the other day. Oh, okay. So we have our original. And now we have, oh, let me be consistent with my colors. We have our second one. So this is us doing the sequences ourselves. So the second one is going to be a dilation of the original by 1/5. So dilating, remember, is multiplying. So multiply by 1/5. So take all these numbers and multiply by 1/5, multiply, multiply. Again, you have that fraction button in your calculator. So -5 times 1/5 is -1. 5 times 1/5 is 1. 0 times 1/5 is 0. -10 times 1/5 is -2, and this is 0. So now let's draw this. So -1, 1 is A prime. 0, 0 is B prime, and -2, 0 is C prime. So we have this little triangle right here. Okay, then our next one, translating that image 7 units to the right. And we're going to come up with our new shape. So take A prime, 1, 2, 3, 4, 5, 6, 7, and that's going to be A double prime. 5, 6, 7, B double prime, Here's C prime, 1, 2, 3, 4, 5, 6, 7. C double prime. Okay, so let's get those coordinates. So 6, -1, or 6, 1, excuse me. Oh, it wants a DEF. Oh, DEF. So that's D. E has to be the new B prime. So E is 7, 0. Okay, 7, 0. And then F has to be what would have been C double prime. And that's 5, 0. Okay, so what they want us to do is not show the middle one. So I guess I probably shouldn't highlight it, because really what you're going to do is you are going to erase this middle one, because it only wants one figure from the beginning to the end. If I was to dilate this yellow triangle by 1/5 and then translate to the right, what would it look like? So this is actually your answer. Okay, so no highlighting that middle one. This one just stays the first one. So it was a sequence of transformations, but we wound up, we showed the middle one to help us get to the third one, but actually didn't have to be there at all. So it just wants one answer, and this technically would be your final answer. Okay, next page. Let's keep it moving. So describe a sequence. So now we're back to what we did in the first page. A sequence of rigid and non-rigid motions that could be used to show that each pair of figures is similar. For each problem, assume that triangle 1 is original. Okay, so these ones are actually saying similar. So I guess I'm going to assume that we're going to have some dilations. And if you look, yep, you see different sizes. Okay, so this is definitely more difficult than the first page. The reason it's more difficult is because you essentially have what you have right here. You have the beginning one, and you have that third one, and you have to figure out, well, what was the second one before I got to the third one? So for here, it was a dilation because it got smaller, and then I moved it over. So that's really what we're doing here, is I have the first one. Okay, this is my first one right here. And then I have the third one. And, oh, wrong color. The third one. And I need to figure out, well, what was that second one and what happened? Okay, so this is as tough as it gets. As tough as it gets. All right, so basically, if you guys just pick out what type of transformations it is, I'd be happy. So first of all, I think the biggest thing that you could pick out and you could see is that they're different sizes. So different sizes, you know it's going to be dilation. Okay, and even if I don't use the coordinates, you see that this is 1 unit and this is 1, 2, 3. So this got bigger by a scale factor of 3. The other thing I want you to notice is for here, the E is on the right, but here it's on the left. So how did it go from the right to left? How did it go to the opposite side? Well, that is reflection. So essentially this was reflected over, so 1 to the right, 1 to the left. This was reflected over this y-axis. This is how we got N prime, E prime, and O prime. And then it took this figure and it dilated it. Okay, so it was a reflection to get to the second one and a dilation to get to the third one. So it's going to be reflection over the y-axis, and it's going to be dilated by a scale factor of 3. And that would be rigid. Okay, so another tough one. So we have our beginning, that's our first one, and we have our end one. Okay, that's our third one. And somewhere there's a second one, but it's hidden and we don't see it. Okay, so again, like the previous one, we notice that we see a dilation. Okay, and that usually happens last. And actually here, the N is on the bottom and this is on the top. So how do we get from the bottom to top normally? It's going to be reflection. So this is going to be another reflection. This time we're going to reflect over the X. So this essentially, 1 down, 1 up. This would be E prime. 2 down. 1, 2, 3. 1, 2, 3. That'll be M prime. And this would be O prime. So this is what the second one would look like if it was actually there. So now how do we go from the second one to the third one? It gets bigger, it's dilation. So pick one of the ones that's easier to count. This is 2 spaces, and this is 1, 2, 3, 4 spaces. It doubled, so that's your dilation of 2. So reflected over the x-axis and dilated by a scale factor of 2. So don't get discouraged with this. Just go back to your basics, okay? You know a reflection means the items, the shapes look opposite. You know a dilation means the size changes. So just as long as you know that, you'll be okay on the final exam because it's going to be multiple choice anyway. So just know your basics. All right, looks like we got one more tough one where we have that missing. So let's see. So we have our original. Again, I know it's the original because it has no letters. And then we have our final one, and we're missing. So again, I know it's going to be similar right away. I see it's going to be dilation. That's going to be the last one. And this time I noticed that the E is on the top, the E is on the bottom. But unlike these ones where you could, fold this over, and they would match up. This is not really going to fold onto this one because they're not really on opposite sides of the, they're kind of one on top of each other. So it's not going to be a reflection over the X and the Y. You can either say that it is a rotation of 180. So this figure, turned upside down. Hopefully that's what you noticed right away. It was a turn. Or you can say reflection over the origin. Okay. So it's going to be rotated 180 degrees, which is the same exact thing as reflection over the origin. All right, so let's see if I can do that now. Can I figure this out? Yes, I can. So 0, 1, 2, 3, 4. So would go to -0, which is no such thing, -4. So 1, 2, 3, 4. So this would be where the E is, E prime. -4, -4 would now be, would go to +4, +4. So actually, O prime would be all the way up here, and that would make N prime all the way over here. So this is what that middle one would have to look like. No, you don't have to draw the middle one because they didn't ask for it, but I just wanted you to see it. All right, so now we're going to go from this middle second one to the smaller triangle. So I know it's going to be dilated. And I want to say a scale factor. All right, so pick something that's easy to count. So 1, 2, 3, 4, 5, 6, 7, 8. 8 to 4. Okay, 8 to 4. So how do I go from 8 to 4? I have to multiply by a quarter, excuse me. So a scale factor of 1/4. If you want to practice with the coordinates itself, this is going from -4, 4 to -1, 1. So what did I multiply -4 by to get it to be -1? What did I multiply 4 by to get it to be 1? And that's 1/4. Okay, because 8 divided by 4 gets you 2. All right, these are really tough. Hopefully you're just trying your best. Number 9, which sequence of transformation? So this is, I guess, more similar to what you're going to see on your final. The final will have all 3 shapes there, though. Which sequence of transformations takes A to B? So again, this is your original. This is the one that you're starting with. And then this is that third one. Okay, because it's sequence, so it's going to be more than one. So how do I go from here to here? So always study what these are. So I see reflection, translation, rotation. So it kind of is going to help you figure out which one it is. Oh boy, this is really hard. Okay, so I know they face in opposite directions. Okay, they definitely face in opposite directions. And if this one moved up a little bit, I could fold it over. So that right away is telling me I've got to have reflection. Rotation, it would definitely, this shape would be more like on its side or upside down. And that's not really what that looks like. It doesn't look like it's on its side or upside down. So my rotations are no good. And now if I reflect it, it's got to go this way. I got to fold it over this line, and that's the y-axis, so I know it has to be this one. So I'm going to reflect it, and I'll just show you what it would look like. So reflected over the y. Here, negative 9, 4, 9, 4, and negative 8, 9. It would look something like this. And then, oh, sorry, it looks so bad. And then basically this shape was translated 2 units down. Translated 2 units down. Okay, so that's number 9. Oh, last page. Last page. Figure Q was the result of a sequence of transformations on figure P. Okay. Figure Q was the result. So this is what we started with. This was our first one. And then this is our third one. Which sequence of transformations can take figure P to figure Q? All right, so again, analyze what you have. So your reflection, translation, translation, and rotation. Okay, so these, what's the best way to describe this? Definitely need some sort of reflection in there because they are facing in opposite directions. And if I rotate it, it really wouldn't be, oh boy, this one's really hard. Reflection over the x-axis and translation 7 units right, reflection over the y. Well, I think the best way I could tell you to start is look at where it's reflected. It looks like it's up here. And remember, it can't just go right to rotation because that would just be in one step. So this was actually now, and oh, I'm not going to be able to draw this too well, but this had to come down here to look like that. So what kind of transformation was that? Well, that's a reflection from the top to the bottom, the second to the third. That's going to be reflection over your x. So this is the only one that even says that. It couldn't be over the y because over the y would be still, 1, 2, 1, 2. It would still be facing this direction. So it can't be over the y and then move down. So that's no good. 1 unit to the right and then rotating it, it wouldn't be in this box. Yes, a rotation's no good. All right, so that's choice A. And number 11, the vertices of a triangle are located at F, G, same thing. A sequence result. Okay, so this is our original. They just don't have it drawn for us. So -4, -2 is F, 2, 2 is G, and 0, -4 is H. So this is the original. Okay, they tell us that this is the original. And then it says something happened to get to our, notice that they just use single primes, but really this is the third one. Okay, this is really the third one. So this one you can see looks very different than this. They definitely have a rotation going on, definitely have a turn, and the size is different. So it has to be a dilation. Okay, so they all say dilation, but notice 2 of them would be an enlargement and 2 are a reduction. So definitely always use your multiple choice to help you. So from the original to the end, it got smaller. So smaller has to be a fraction. So A and B have to be out. So now we're either going to turn counterclockwise, which is to the left, or clockwise, which is to the right. So from here to here, I went with the clock. Okay, I went with the clock. So that's going to be clockwise. So again, your 2 fractions, that's going to make something smaller. Those 2 things are going to make something bigger. And this is your original. Okay, so your homework tonight is just 4 questions. I definitely gave you the more basic ones. I gave you the ones that, you know, had all 3 of them there to make your life easier. So just look at the letters. You want to give me for each one, you want to give me the 2 transformations. So from the first transformation is the original to the first image, and then the first image to the second image. And then also tell me if they're congruent or rigid. So you're just telling me, again, for each of these 4, you're telling me what the 2 transformations are, the sequence that got you there. And then you want to tell me if similar or non-rigid. Again, try your best. On the final, this is multiple choice anyway, so you guys will be okay. Just try your best, and I'm proud of you. All right, so make sure you put this on Google Classroom. This is it for transformations, and then we will start our next unit and our final unit of the year, which is statistics. All right, have a great day. Try your best.